All right, I am going to get started. So good morning, everyone, and good afternoon and good evening to everyone who's joining us from other parts of the world. This is, of course, the August release webinar for HAPI FHIR 4.0.0, which is exciting, as well as for Smile CDR 2019.08. We will be, this is, of course, this is the Igloo release, codename Igloo. And just a reminder to anyone who hasn't joined one of these things before, we do releases every quarter. So every 3 months, we're doing a regular release these days. So the next release will be in November. We are recording this session, and a link, of course, will be made available as soon as we're done here. So if you have to leave or you want to share this with other people, don't worry, we will make a recording of everything available after the fact. All right, so I'm going to start by saying hello to you from our new home. The Smile CDR team moved just 2 weeks ago into a new home. We're now in Little Italy in Toronto. To anyone who's not familiar or who is familiar with the city, we're in a building that's kind of famous, known as the Chin Building. I'm actually speaking to you 1 floor down from a radio studio, oddly enough, where CHIN International Radio is broadcast out of. So kind of a neat little thing. To anyone who's located in the Toronto area, we would absolutely love to welcome you by our new space. We're very proud of it. So come on by and say hello. We would love that. This is a shot of the outside of the building and one of Toronto's iconic and soon to be replaced streetcars sitting outside it. So today's agenda, as always, we're going to talk about what's new in the new release of HAPI FHIR. We're going to talk about what's new in the new release of Smile CDR, and we're going to talk a little bit about what we're currently working on. So what's coming up in the next quarter for next release. These slides, as are basically everything I ever do, are Creative Commons licensed, and we will make links to them available afterwards as well. So this is a big release as far as we're going. We rarely sort of bump up the major release number in our releases. We've, the previous release was 3.8, and there were 8 releases in the 3 series of HAPI FHIR. We decided to bump the major version because this release has some fairly significant changes, including a few breaking changes. Breaking changes are not something we do lightly. They're always something we consider very seriously, and every once in a while we realize that we've sort of hit a point where we need to make some fundamental API changes in order to continue moving forward. I don't think any of the changes are going to cause particularly big headaches for any users, but I think it did merit bumping the major release number. We're quite excited because going along with a few breaking changes, there are just a ton of new features in this release. It's probably the biggest release in terms of density of features that I think HAPI FHIR has ever had. And that's pretty exciting. Certainly the pace of change in HAPI FHIR has only been going up the last while, and new features are bubbling into it like crazy. So let's go through a few of the new things that are in there. First off, we have got support for the draft R5 resources. This is something that's really mostly interesting to people who are working on the FHIR standard itself, but it could well be interesting to people who want to keep on top of what's coming and prepare themselves for the next major release. R5 support is available throughout the library, and that certainly includes clients and servers, also includes the JPA server, and notably it includes our public test server for HAPI FHIR. So I've got a URL here. If you were to click on that link, you would go straight to a draft R5 endpoint. And if anyone would like to host one of these themselves, of course, that's all in the library now. So R5 support coming along, it's great. Next thing. Ooh, what's going on here? Consent Interceptor, there we go. The Consent Interceptor, to anyone who was at the Dev Days event in Seattle this year, you would have seen me speaking about this new feature called the Consent Interceptor. I'm a little bit pressed for time, so I can only scratch the surface of how cool I think this thing is. But The general idea with consent interceptors is that we sort of recognize that it would be impossible to ever write a consent framework that met everybody's needs. So we've taken to writing an API-based approach where we've basically provided a really nice framework in HAPI FHIR that allows you to make apply policy decisions, apply consent resources, potentially reduce results from search results, potentially mask data, potentially author new audit events, potentially look at various consent directives that have been applied either at the individual level or at the system level or anything in between. There's a whole bunch of flexibility in there, and I'm really only scratching the surface here. But the whole idea is that HAPI FHIR has had for a long time the authorization interceptor. The consent interceptor is the other half of the security pie as far as I'm concerned. So, effectively, if you're building up a big sort of secure system, this is another tool in your tool belt that will help you do that. I'm just going to show one quick teaser from the Dev Days presentation. I'm going to make that presentation available at some point soon. I'd probably get a bunch more documentation written on how these things all fit together, but just to sort of whet your appetite as far as this stuff goes, you can see that the authorization interceptor is used for making the pass-fail decisions about whether the user's permissions allow them to do things, and then the consent interceptor steps in and decides, is data that's about to be disclosed appropriate for the user who's seeing it, and should we be redacting it in any way based on policies. So very interesting sort of framework in terms of ability to secure your systems, which is great. The next major thing that's gone in is full support for GraphQL. GraphQL has been this sort of funny bit of the FHIR spec that lots of people are aware of, but not a lot of people take advantage of. I suspect a big part of that is the lack of available tooling for that. We've had some experimental support that really only supported FHIR or R4 and was fairly incomplete in HAPI FHIR for a while now. At this point, it has been backported to R3. It has been integrated with the authorization and consent interceptors, meaning it's completely secure at this point. And as a little bonus, the response highlighter interceptor, which of course gives you that nice HTML view of your responses when you're testing in a browser, also supports GraphQL, so it's able to do nice syntax highlighting on that. So I've got a link here. Afterwards, if you get these slides, you can try clicking on that and seeing what GraphQL actually looks like. Very cool stuff for sure. Equally cool, if not even more cool, is another feature that's been added called the filter search parameter. This is another one that is incredibly powerful, and I could spend the next hour talking about it. It's just that good. I'm not going to, because I don't think we have time for that, but I will say two things about filter. First off, this was implemented by Anthony Soot, and we really appreciate his contributions there. Anthony has been incredibly patient too with me while I've worked at trying to get this thing merged. It's been a momentous thing trying to get this all integrated with HAPI, all of Anthony's great work. So certainly thank you, Anthony, for all of your help on that feature. A little bit about what filter is. You can see the best way to sort of describe it is to just show an example, and I've got one up on the screen here. Underscore filter is a standard search parameter that is defined in the FHIR specification. So this is a formal part of the FHIR spec. And it defines an incredibly powerful grammar for expressing searches that goes well beyond what's possible with traditional REST search parameters. I've got a simple example sort of showing some order of operations. It's got a bracket syntax. It allows all kinds of complicated expressions. So it goes well beyond what you can do with regular search parameters, which is quite neat. I do caution, of course, that it's the underscore filter is a bit of a double-edged sword. It certainly allows you to write queries that do not have indexes in the HAPI FHIR JPA database by default. So certainly it would allow you to create queries that perform quite badly if you knew what you were doing. As such, we kind of recommend that it not be used in servers unless you've got some understanding of what your clients are going to be doing, and you are able to you've got a database administrator who's able to tune indexes and things like that to make sure that any queries that are written will perform well. But assuming you meet those criteria, I think this is an amazing tool for people to use. This is enabled on our public test server now, so this link will work if anyone wants to try it out or play with it. We absolutely welcome feedback. This is a brand new feature that hasn't seen a whole lot of battle testing yet, so any feedback we can get would be awesome, certainly including any bug reports anyone can find. The new Interceptor framework that I spoke about on our last webinar continues to grow. We've added a whole bunch of new point cuts. And our general take these days is that absolutely every single thing that's going on anywhere in the framework, if it's of any note at all, should probably have a point cut so that interceptors can hook into it and add their own logic. We've added a bunch of interceptors, point cuts around access to data. A lot of that was added to support the consent interceptor, but certainly could be reused by other interceptors, including ones that you might write. We have worked a bunch on point cuts for deletion operations, just because they've been a hot topic the last while, allowing people to block deletes, to handle conflicts without rolling the change back, all kinds of other exciting stuff. And perhaps most excitingly to me is a set of interceptor point cuts for performance tracing in the JPA server. The last while have seen a number of people using both HAPI and Smile in very sort of large scale deployments. And we're realizing that for that type of thing, it's very useful to have some insight as to what the server is doing on an individual query. So we've added a bunch of point cuts that can be used for adding interceptors that are tracking the performance of an application and sort of logging individual parts of what's going on during a FHIR transaction. I'll show you a little bit on one example of how we've used that in Smile CDR a little bit later. Patch. So Patch has been a surprisingly popular feature the last 3 months. I don't know what changed in the last 3 months that caused people to get really interested in Patch, but we've had just an endless stream of people coming and saying, hey, I'm trying to do X with Patch, and either I can't figure it out or it's not working, or just awesome, I love Patch. Lots of that. If you've never played with Patch before, of course, Patch just allows you to apply sort of incremental updates to a resource. So without posting the entire contents of a diagnostic report, for example, you might update just the status with a tiny little transaction that says set the status to complete. That's done with Patch. The biggest thing that happened in the world of Patch with HAPI FHIR is we have completely rewritten the JSON patch support. We were using a really old sort of beta library implementation of the Patch specification before. We're using a much more solid one at this point. We've completely rewritten all of HAPI's wrappers around that. And all of this causes Patch to be a whole lot quicker, certainly a whole lot more robust. And most importantly, if there's anything wrong with your Patch syntax, you get great error messages now. Previously, you got just a really boring patch not valid error message, which people never found very useful. So patching is really good now. Cascading deletes. This has been an endless request on HAPI FHIR for all kinds of reasons. People often get tripped up by the fact that HAPI enforces referential integrity, by default at least. That is a thing you can turn off, but if referential integrity is enabled, then certainly you are not able to delete a patient if you've got a bunch of observations that link to that patient. Oftentimes, and most often you see this in testing scenarios, people want to go and delete that patient and have all of their observations automatically delete as well. So a new search parameter called _cascade has been added that allows deletes to sort of do this cascading effect. That is really nice for cleaning up after tests as one simple example. And I should mention this is disabled by default. So it's something you have to manually enable if you want to support cascaded deletes. And it occurs to me equals true is not the right syntax anymore. I wrote these slides thinking or forgetting that we had changed the syntax a little bit. So I should patch my slides, I guess. But if you check the HAPI FHIR documentation, you'll see the correct syntax for that. I think this is the last new HAPI FHIR feature I'm going to talk about. This is binary storage. So another thing that's been surprisingly popular in the last while is people are starting to use HAPI FHIR servers and FHIR servers in general, not just for storing traditional sort of, text structured data, I guess we should say, but also for storing large binary content as well. So maybe storing a diagnostic report and including a PDF version of it or a DICOM image or anything like that. So a new module in HAPI FHIR called the binary storage module has been added. And binary storage effectively allows you to offload the storage of these large binary blobs out of the relational database and into a dedicated file system, which has all kinds of nice properties, including allowing you to use a network mount if you've got a cluster of servers. Certainly avoids the nuisance that comes with trying to scale databases for really large files. So you get a lot of advantage from that. The way the feature works right now is with 2 custom operations that have been implemented in HAPI FHIR for setting and retrieving binary content. And this has this really nice property that when you use these features, these operations and the binary storage module, you never actually load the contents of the file into memory as you would with a traditional resource, which means that you're not bound by the amount of available RAM if you're trying to store really, really big files. So this is really nice for scalability and has proven quite nice for a couple of deployments that are doing this type of thing. In terms of what's changed, I should mention this is kind of an infrastructural thing that won't have a significant impact on most users other than with one big change I'll mention in a moment. Previously, right up until HAPI FHIR 3.8, we have been regularly syncing code out of the org.hl7.fhir.core GitHub repository, which is a bit of a mouthful to say. And what this means is that the patient.java class, for example, for R4, lives in that code repository, which it is in GitHub under the HAPI FHIR organization, but it's a separate GitHub repository from the main HAPI FHIR project repository. So we have regularly copied all of that code out of that repository and into HAPI FHIR. We've decided to stop doing that and now depend on that library via Maven dependencies. So again, this is mostly a transparent thing if you're using a build system like Maven and Gradle, because you'll get these new jars automatically pulled down, which is nice. The one sort of thing that we decided we had to do just to make all of this migration possible was a rename. So if you are a user of the hl7.org DSTU2 structures, and this applies only to DSTU2 structures, not any other version of FHIR, and it applies only to the hl7.org version of those, so not the ones that start with ca.uhn.fhir. That set of structure classes has moved packages. So what was previously org.hl7.fhir.instance.model is now .dstu2.model. This is kind of a nuisance change. We've had to migrate a couple of applications ourselves. I will say you can get at this with a couple of find and replaces in your code base at least, which is kind of nice. So if you do a global search and replace for the first string and replace it with the second, that type of thing will make this a little bit of an easier change. I will say, I realize this is a nuisance to people. This is, again, not something we take lightly. I hate making breaking changes, and we have tried really hard over HAPI's long project lifecycle, almost never to make breaking changes. But there is the odd time that it's necessary. I don't want to go into all of the details here about why this change was necessary in terms of our migration from org.hl7.fhir.core. But I will say that the benefit of doing this is that it's going to allow us to be much more responsive to fixes in things like the validator, the R5 structures, the FHIR path implementation, potentially the new mapping frameworks that are coming along in the FHIR spec. So we're going to be able to keep up with new features in the FHIR spec much more quickly, thanks to a bunch of sort of cascading changes that stem from us dropping this old hl7.fhir.instance package structure. So if anyone wants to discuss this change, of course, the HAPI mailing list is a great place to start. Hopefully this doesn't cause too much pain for people out there. So on to Smile CDR. Smile CDR itself has, oh, you know what? That's a copy and paste error. There are no breaking changes in this release of Smile CDR, but there are lots of new features. So a couple of things that have been added. First off, we have been hard at work developing an EMPI module that's sort of native right within Smile CDR. To anyone who's not familiar with EMPIs, they are sort of master data management solutions that can be used to automatically link different resources that represent the same physical entity. So the best example is I'm collecting patient resources from a bunch of different systems. I want to sort of cross-reference which two patient resources actually represent the same real-world person. An EMPI is a piece of software that will do that for you. FHIR's actually got some really nice infrastructure built into the specification for supporting EMPIs, including the person resource, which is used to store links between patient resources, as well as an operation called $match, which can be used to search. What we have been working on is adding support for all of this stuff right within Smile. So there's a brand new module that's in there. If you'd like to use it, we would love to chat with you. It will be there via a toggle in the August release of Smile CDR, and we're actively sort of testing this and welcoming feedback from anyone that wants to try implementing against it. The performance tracing that I was talking about previously has made it into Smile CDR. We've taken advantage of all of those interceptor hooks I was describing before to add a bunch of insight into how queries are performing, and I'll show you two examples of those. One, it's a little bit probably hard to see, but a bunch of new headers when this stuff is turned on are enabled. And those headers give you insight into the SQL that we generated, like what went to the database, a little bit of insight into how quickly the database responded to individual queries, as well as sort of any warnings that might come up. So if you've made a query that is, for which no index exists, or there's a way you could modify your query so it would perform better, you'll see sort of insights right within the response window. Again, this is a feature you have to turn on because it does come with a bit of overhead, but if it's turned on, then you'll see sort of additional response headers like these ones. All of those same messages end up in the transaction log as well. So if you are reviewing transactions that have gone through your FHIR server, you've got a bunch of insight here as to what has happened, and those same warnings will show up here as well. Incidentally, and this applies both to HAPI FHIR and Smile CDR, all of this performance tracing is not an all or nothing. You can turn it on globally, you can turn it off globally, but you can also enable it per request, and that takes advantage of an additional header. So if you wanted to performance trace only a single request, you can do that by adding an extra header that you send in your request. We have added support for two-factor authentication. It's a constant favorite these days. I mean, I try and enable TFA on everything I possibly can in my life. I think most people should. We have added support for the TOTP protocol, which is more commonly known as the thing that powers systems like Google Authenticator and the Authy app that are quite popular. So there's lots of free implementations out there of TOTP, which is nice. And if you'd like to add support for that, we now support it in terms of authenticating smart apps. If you're using our OIDC services within Smile CDR, it's also possible, it can also be set up for authenticating access to all of our web admin tools. So that is obviously a good thing, definitely good to secure things as much as you can. And TOTP is really quite a nice way of doing that. We continue our constant work at enhancing how subscriptions work. Subscriptions are just ever popular with people who are implementing FHIR servers. I always say they're really pretty much my favorite part of the entire spec. I think there's just so much power in a subscription. Smile, of course, has native support for Kafka as a backing store for subscriptions, and we implemented that in the previous release cycle in order to support much better scalability of the subscription modules. These days, a bunch of new settings have been added in there, including thread pool and consumer counts that you can tweak, as well as encrypted transports if you've got a Kafka server set up that needs TLS encryption on its transport. So that's all in there. And our work continues with Kafka as well. We've got a bunch of plans for the next release cycle to further beef up scalability of subscriptions via Kafka. So more to come on that, I am sure. We now have, and this is something that we've had quite a few requests for, support for Docker and Kubernetes-based deployments. Certainly, you don't need to use Kubernetes to use Docker. We have a standard Docker-based image that is available as of the 2019.08 release. But we've also got recipes for setting up with Kubernetes. So if you are, if your infrastructure includes using Kubernetes to provision potentially very large, wide clusters of applications, Smile will happily play in that landscape as well. And all of this includes very complicated clusters. So we've got a few people that have these big multi-master clusters where various masters are performing different roles within their Smile CDR deployment. All of that can be scaled up with Kubernetes, and it certainly is possible to take individual parts of your deployment and scale them up independently of other parts of the deployment via the multi-master cluster feature. A bunch of work has gone into terminology management in the last while. We've had a few people actually come to us with ideas around wanting to keep sets of terminology up to date without ever taking their server down. So to support that, we've added two new operations, the apply delta add and apply delta remove, which allow you to dynamically add and remove codes as well as hierarchies of codes from a code system without ever taking your terminology service down. So in other words, without having to re-upload your master code systems, which is kind of nice. We've also added a CSV-based importer for your code systems. So previously, we've been able to take in Loink and SNOMED CT code systems using their standard export formats. These days, if you've got your own code system, as long as you can present that as a CSV file, that can be uploaded in just as though it, using the same upload functionality that was available for Loink and for SNOMED CT. So that's kind of neat. Every one of the HAPI FHIR features I've described are also available in Smile CDR as of the latest release. So certainly that includes the consent services. And additionally, in Smile CDR, your consent rules can be written not just in Java, but also in JavaScript via our JavaScript APIs, which is useful for some people. GraphQL and _filter have been brought in, of course, and these are secured by the same authorization layer that secures every other part of Smile CDR. Binary storage has been brought in, of course, cascading deletes, and really everything else that I've described. That has all been brought into Smile CDR in this release. So a little bit on what's coming up and what we're going to be working on in the next little while. We're definitely not done with binary storage. This is, I think, really just the tip of the iceberg as far as the binary storage module is concerned. We've got some plans to implement backends that are backed by standard cloud storage mechanisms. So S3 is the obvious one. If you'd like your binaries to be offloaded into S3 buckets, we've got plans for that. But Azure Blob Stores, as well as the Google Cloud Platform equivalent, whose name I'm completely blanking on right now, they've got one as well. And certainly we intend to support that, as well as sort of automatic use. I was talking about how there are two FHIR operations that are used for binary storage today. We plan on beefing that up so that you don't need to use those operations if you don't want to. So if you're uploading, for example, a document reference that has a large attachment, that will automatically be shuffled off into binary storage. That doesn't happen today, but hopefully within the time frame of the next release, that will happen as well. So that will be good. One of the big things that's going on, and this is thanks to our ongoing partnership with the Reagan Street Foundation and their Loink group, we have been working with them to implement a number of enhancements to terminology services in HAPI, and one of those is around value set pre-expansion. What this means is that today when you expand a value set, and that's either to get the complete expanded value set or more often to validate codes that exist within that expanded value set, right then and there, we will perform the expansion. So we've got a developer here who is hard at work at setting things up so that we will pre-expand value sets when they're uploaded and keep those value sets stored in the database, potentially also stored in memory so that we can do lightning fast validation against those. We also get a couple of other nice features like being able to page through value sets, which is great for things like the Loink implicit value set, which just includes all of Loink codes. In the current version of HAPI FHIR, if you try and expand the all of Loink value set, you get an out of memory error and no data back. With value set said, pre-expansion complete, and that this is almost done at this point, you will get a nice paged result that allows you to page through everything that's in there. So that's going to be really useful, I think. One of the features we're working on the Smile side of the world is an alternate backend that doesn't use relational database, but instead uses MongoDB for storage. We're doing this to support use cases that require extremely high throughput for data sets that are, I will say, document oriented. So this is data sets that don't require referential integrity, between, for example, your patient and your encounters, but do require extremely, extremely high throughput. And we're thinking here thousands and thousands of transactions per second. Mongo is a really nice platform for that type of thing. It scales really nicely, including it's got very good geographic scaling capabilities. So we're hard at work at setting up a MongoDB backend that will support that. This is targeted for November release, but certainly we'll have experimental builds available much sooner than that. So if you're interested in testing the MongoDB backend, we would love to hear from you, and we'd certainly be happy to support you in that. Another feature that's coming, and this is a really difficult one to explain, but an extremely exciting one for us, is LiveBundles. LiveBundles effectively allow you to create these predefined collections of resources that are kept warm and are available for really, really fast query. The best sort of example of that is, let's say you're building an application that needs a dashboard, and that dashboard will have lots and lots of rows, maybe representing all the patients in a clinic or all the patients in an entire network or something like that. And then all of your columns represent various things that are retrieved using a FHIR query. So, one column might be give me the last 5 test results for a specific lab test. The next column might be find me any active conditions for that patient. The next column might be, perform some calculation. What's been their average body temperature over the last 5 days or something like that. LiveBundle allows you to keep all of that data sort of warm and ready for query as a single bundle, which means that you're not performing, potentially 100 rows times 10 columns worth of FHIR queries, and then maybe even performing calculations on that. You're performing a single FHIR operation that returns a bundle that has exactly the data you need and only the data you need. So LiveBundle is a really neat feature, and I'm hoping I've done justice to sort of the power that's in there. I'm sure Ken on our side will criticize me if I've got it wrong, but I think I've got it right. That sort of is where we're at with that. LiveBundle is very close to being complete at this point. We've got it in the hands of one group who are testing it, and we're in the middle of finalizing sort of configuration management for how it looks and writing a bit of documentation. So that will be available very soon. And again, if you'd like to try testing LiveBundle, that's another feature that we would love to help you get testing. So that is it, and I am exactly on time for where I wanted to be. I will say this release, both on the Smile CDR and on the HAPI FHIR side, these were really big releases, bigger than usual, in fact, just because we had a number of sort of long-running things we've been working on that spanned multiple releases and just could not land in time for the previous release. So they got carried over, in some cases over 2 releases. All of that stuff has landed in this release. So this is just a phenomenal release for both of these products. I haven't covered everything, but certainly the change logs will give you details as to what has changed on both HAPI FHIR and Smile CDR. Sadly, I ran out of time, and we did not get the change logs updated on our website for either of these in time for this webinar. So I'm going to be doing that this afternoon. So I would say, check back tomorrow. Absolutely, by tomorrow, the change logs will be up and live on the website, and you will get a final view as to what has changed across these 2 products. So once again, thank you to everyone who joined us today for our release webinar. I hope this was useful. We would love to hear feedback, and most importantly, as I said, we've been recording, so we will make a recording of this available shortly. Thank you all. Bye-bye.